is great to see you here again. My name is Luc de Kuster, founder of the Kuster Academy. And in this lesson, in this video, I will talk about Scrum progress and end date estimation. And I will look at the principles and at some exercises. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look at some calculations and the principles. One of the things what we want to do when we start with a project in Scrum, we want to estimate how long the project will take. Now, one of the problems with Scrum and Agile is that we don't really know, like we used to know in a waterfall project. We were estimating all the activities, the duration, we created schedules, so we made a very nice planning. But in Scrum, we don't have that. So how do we start? Now, we have to start at the beginning. First of all, when we look at all the stories, remember the Fibonacci poker system, where we allocated points to the activities based on an estimation, small, extra small. Some people use dog breeds, but anyway, there is some number linked to all these elements. And the Fibonacci poker is the easiest one to remember in this case, because we already have the numbers. So what's the first step? We calculate the total project effort. And we add all the story points to determine the total effort of the project. Just say the total effort is 200 points. Now we have to estimate the velocity. Now, when this is your first Scrum project, it may be difficult, but you can investigate or consult to have an intelligent estimate. You can use your experience from classical waterfall projects to find out how long it will take, but also when you have experience, you can already have a better estimate of the velocity based on past experiences. Step 3, we do the duration estimate. You divide the total effort by the velocity to find the number of iterations. Since you know the number or since you know the duration of the iteration, you can determine the total time. For example, a sprint of 2 weeks, you multiply the number of iterations or sprints with 2 to get the number of weeks. Let's put this in an exercise. The total effort is 200 points. The estimated velocity is 20 points per iteration. The duration of the sprint in our case is 3 weeks. So we have a number of sprints, which is the total effort divided by the velocity, which is 200 divided by 20, which gives us 10 iterations. An iteration is 3 weeks. So basically our project will take 10 times 3 is 30 weeks. Very easy to calculate, but once we have the numbers, once we have the effort, that's easy to get. The more difficult thing to get is in fact the estimated velocity. Now remember PERT 3-point, we can also use this on our estimations. And we don't always have a correct estimation, and they may be subjective, but some experience may help us. We can calculate the average velocity over past projects and the standard deviation. When we have a lot of past projects, we can look at it, we can see what is the standard deviation. Or we can use also the calculations that we did before using the PERT or the 3-point formulas. Basically, here we also get an average and a standard deviation. Now, when we want to calculate the velocity with 85% probability, this is close to the average plus 1 standard deviation, and we can use this value for estimation. Basically, this gives us a better estimation. Average plus 1 standard deviation is like 84% probably, so 85 is not far away. Let's take for the simplification 1 standard deviation and use that value. Now, we have now an initial estimate that can be refined, for example, also by adding a weight. When we have more complex project, we can look at the weight of the project. We can add some coefficient to increase or decrease that value based on the complexity. Once the sprints start, we can calculate the actual velocity of this project. Let's have a look at the second exercise. Here we have a project with an effort of 300 points and the velocity data, optimistic 20, probable 18 and pessimistic 14. Be careful here because optimistic and pessimistic is a little bit different than in the other case. Here we want to have the highest velocity. So 20 is the optimistic and the pessimistic is 14. It will make a small change in our formulas when we calculate the standard deviation. What is the expected duration of this project? Well, we can calculate the 3-point velocity. We just take the average and I find 17.3 points. 3-point standard deviation. Now we take 20 minus 14 divided by 5 is 1.2 points. It's always a positive number. And in this case, we can say that the new estimate is the effort divided by the 3-point velocity plus 1 standard deviation. So we have 300 divided by 17.3 plus 1.2, which is 17.14. Of course, we cannot have 17.14 sprints, so we round up and we say we will have 18 sprints. We could also say it could be 17, depends how things go. In general, we may have the idea or we expect that our velocity will improve. So we could say, well, typically we could also say 17, but basically I would round up to start with it. So that's one element that we can do. Another calculation is to determine the remaining duration of a project. Now, once a project has started, we can determine the velocity of each iteration and use that to determine the remaining duration. Step 1 is we have to measure the sprint velocity. So every time we finish a sprint, we know how much or what their velocity is, and we do that for all the sprints that we have completed. We can calculate the average sprint velocity, or we can just take the last one. There are different ways to do it. We have simple averages, weighted averages, limited series averages, also what we had in forecasting, and some probabilistic average that we can define. I would keep it simple to start with a simple average, but it depends on your experience, what you have seen. I would not take all the sprint values. We can limit it to 3 or 4, and we have to see how it is going, what is the evolution. This is basically on your experience, and you will learn from it by doing the different projects. You will anyway see how this evolves. The step 3 is to calculate the remaining duration. Now we know how many points already have been completed. We know the total number of points of the project, so we make the difference. We have the remaining number of points, and with the remaining number of points, we divide it by the velocity that we calculated, and we find here the remaining number of iterations or sprints, and then we can calculate the remaining duration. Let's have another exercise here. Let us consider a project with an initial velocity of 20 points per iterations. Total points for the project is 300 points. And after the first iteration, we find a velocity of 15 points. What's the initial and expected duration of the project? Initial duration, we take the total effort divided by the estimated velocity. So we have 300 divided by 20 is 15 iterations. Then we take the new estimate. We have the total effort divided by the measured velocity is 300 divided by 15 is 20 iterations. We don't subtract here the first iteration because it's already the total effort. It's the same thing we calculate from the beginning, but that's just a little detail. Let's have a look at a different exercise. Here we're going to calculate the expected remaining duration of a project in Scrum. And here we have a project with n sprints. In this case, we have n equal to 4. So we have 14, 17, 22, and 25. Total points for the project is 300 points. So in 4 sprints, I already realized 78 points. What is the expected duration of the project? Well, what we have to look at now is to calculate the average velocity of 14, 17, 22, and 25. So we divide their sum by 4, and I find an average velocity of 19.5 points. Now we are going to use that to calculate the new estimate. And the new estimate is equal to n, which is the number of sprints that have already been completed. And we add the remaining durations, or the duration of the remaining sprints. So we have the remaining remaining effort, and we divide it by the average velocity. N is equal to 4. The remaining effort is 300 minus 78 is 222. And we divide that by 19.5. And we find that the new estimate is 15.38 sprints. And we round this to 16. So basically what we have here is that we see that our project is expected to be completed in a total time of 16 sprints. And we already finished 4 sprints. We still have to finish 12 sprints. And that's it for the calculations. So that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos.